afternoon, good evening, wherever you are. I hope you can hear me well and you can see my screen. Our session today will be about security best practice in AWS. My name is Magdy El-Faramawy. I'm a senior cloud security consultant at EY. Little brief about me. My name and my title as a senior security consultant at EY Australia. I hold a number of certification, CCSK from Cloud Security Alliance, CISA from ISACA, and C certificate from AWS. One of those is AWS Security Specialist and the OSCP from Offensive Security. I hold also MBA from France Business School. I have more than 15 years of IT experience. I worked before in Egypt for 2 years. Then I moved for Gulf. I worked there for 12 years. And last 3 years I was in Australia. Recently, this year, I joined EY as a senior security consultant. And here my LinkedIn profile. So our agenda for today will start with introduction and cloud journey and people moving now to cloud. Then we are talking about AWS SRM or shared responsibility model. Then we are going to talk about IIM, identity and access management. After that, we are touching base with VBC, data security, server security. So we are talking about different layer of security, starting from network, data, servers, applications, monitor and logging, auditing, and what AWS security solutions available. And at the end, we will have summary for best practice for security solutions. So why we need cloud security? Cloud security with spreading of COVID-19 increased in the cloud. COVID-19 increased the cloud usage massively and the reliance on cloud-based services. More than 60% of senior IT executives believe security and compliance risk are the greatest barriers to realizing the benefits of cloud. But this number going to be shortened nowadays. There is growing sophistication of cyber crimes and the new cyber attacks. There is a lack of awareness among enterprise and the consumers due to the complexity of cloud computing models. There is a lack of trust in security service providers. So we need to understand with the new situation we are living in nowadays. That's why I am talking from here. I am talking from Australia. I am 2 years back. I was in Egypt. I was introducing my first engagement with Arab Security Conference face to face. But this year we are working in hybrid mode because of this COVID-19 and restriction we have in travel and so on. This increased the demand for cloud because now organizations, everyone working from home, need to access SaaS applications or cloud-based applications. So accessibility from anywhere, everywhere. This increased the demand for cloud, which increased the demand for cloud security. And I want also to let you know that attackers now, they are not attacking organizations itself. They attack individuals because everyone working from home have his own PC or company PC or company laptop. So the attacking happen now on individual level, not on company level or not on organization level. So let's talk about cloud journey. What stages we use to move to cloud? Cloud journey is not just a technical change. It's not only moving a workload to the cloud and what implications, what impact we have, not only that. It involves a change in the entire IT framework, multiple business departments, and the critical business processes. Before we have a team for network, a team for storage, a team for development, a team for backup and restore, different islands. Nowadays, it is cross-functional. So it's entire change, big change happened to organization, big transformation. So we need to translate these business goals into migration plan. This is a time consuming, but we need advanced planning. Planning is the key for successful migration. So I will have you through a journey. I walk through a journey with you with 6 steps. How we are going to start this journey. How we are going to start moving to cloud. Step one, we need to make a business case. A cloud journey is a business decision, so it should come from top to down. A company should start by evaluating the business implication of adopting a cloud infrastructure. Decision makers must understand how the cloud different from traditional IT setup. What's the financial impact? They are going from CAPEX to OPEX. They are going from paying a lump sum to buying servers, data center, uh, air conditioning, race floor, all this stuff we know, to subscription, pay as you go. They need to understand this concept. Our decision makers need to understand this. This is the first step. They must be able to assess the benefits and risk, compliance, security, and the data control implications on the organization as a whole, and the IT activities in particular. And they need to determine what system and the apps should be first migrate, what priorities we have, and what financial impact, which is a very important topic for them. Then, step two, we need to identify the right applications. What is our priority? Because each application has its own unique design, which may know or not fit for a cloud environment. For example, we have organization having uh, old applications or applications running on old operating systems, which is maybe not available on cloud. So we need to understand these constraints before you decide which workload you are going to move to cloud. So if the application is suitable for cloud, we can just lift and shift. This is the expression used in the market. Lift and shift means take it as it is from on-prem to cloud. Otherwise, we may need some changes. So how much change is needed? This we need also to be clear. So the easiest migration are often those that require no code modification. As I mentioned before, lift and shift. This is the easiest migration. But in other cases, some application may need some little tweaking. So what's the worst case scenario? We are talking about the easiest scenario. What's the worst case scenario? When the entire application need to be completely rewritten from scratch because it is not compatible with cloud. So to ensure efficiency and the cost effectiveness, we should thoroughly assess the complexity and determine whether we can completely shift to the cloud or whether it makes more sense to move only some applications and keep other applications on-prem. So it is not always the best case scenario to move everything to cloud. It cannot be like that because it depends on the complexity you have in your environment. Step 3. Select a cloud service provider. After we do internal analyze and we understand our environment well and we understand the complexity we have and we do our priorities, there is a wide range of service provider. There AWS, GCP, Azure, Microsoft, Oracle, and much more. Each offering a distinct architecture that can be unique set of capabilities. A lot of different licensing support. You need to evaluate what fit with your needs. I am not here today to give some credit for AWS or over other cloud providers. No, this is not the case. My session is about best practice for AWS, but this is not any kind of recommendation for AWS over others. So we need to ask this question. Does the architecture of the cloud suit the design of our workloads? So if we do some modification in our application, it might make more sense to choose the cloud environment that require few code changes. What kind of cloud implementation is supported by provider? Because majority of cloud providers now support public and private cloud offering. So if your plan is to implement a multi-cloud or hybrid cloud architecture, we should check if the vendor offer capabilities of complex cloud environment or not. Can we bring our existing license? Because now we have our workload on-prem, we have license already. So can we move our license with us to the cloud? Yes or no? This question needs to be answered to evaluate your cloud provider. What type of support the cloud provider offers? And of course, how much it costs. Because some cloud providers provide you with some tools to support, some other provide some help to migrate, which can be good to help you in migration, and they provide some tools to migrate your current workload. Step 4, initial adoption. So as we know, software as a service or SaaS is usually the first and simplest solution to adopt. Application which has it's not much complicated or less critical business criticality, such as CRM or Office 365, accounting, HR. This kind of stuff can be moved first. But application which has more criticality and business impact and has some integration with core business systems like ERP, this requires deeper and adapting platform more than SaaS. Step 5, full migration. By now, we should have information needed to migrate our workloads. So we have our plan ready. We know our complexity, our stakeholders and the management decision makers know the impact exactly what's going to be happen. However, a huge part of the execution phase is testing. We need to test now. Before moving everything to cloud, we need to test. After we moving this workload to the cloud, what's the impact on our staff? How it works? Is there any issue? So we need to have a pilot. This very important for mission critical application, which cannot have long time of downtime. So you need to test your plan. Then you can start your execution. And one very critical point here, we need to create a backup and recovery strategy. Last step is post migration. After we completed our migration, we complete our migration, yes, but not our journey. Now the time begin for comparing pre and post migration performance. Are we improved when we move to cloud than on-prem? We need to monitor the cloud performance with our provider service level agreement and our own performance goals. This is the 6 steps. Now I will talk especially, I'm talking before I talk about in general what the cloud journey is. Now I am talking about AWS itself. AWS is architecture to be one of the most flexible and secure cloud environment. AWS remove most of security burdens that are traditionally associated with IT infrastructure. I will deep dive into this one in coming slides. Security at AWS is job zero, so it is the starting point. It is first priority for them. AWS is architecture to be one of the most secure cloud environment with a host of built-in security features, which I will explain more in details in coming slides, that allow us to eliminate most of the security overhead that is traditionally associated with IT infrastructure. However, security in cloud is in fact slightly different to security on-prem or on data center. When we move servers, data, and workload to AWS cloud, responsibilities are shared between us and AWS for securing data and workload. Shared is a key word here. Shared responsibility. What is shared responsibility is? Today, when security in cloud is one of the major reasoning organizations are moving from data center to cloud, more and more executives and decision makers and the key stakeholders are vouching that security in cloud is farther ahead and more reliable and economical than security on-prem data centers. Security that is provided in cloud has most of the same functionality as security traditionally we have in IT, such as protecting information from theft, data leakage, and deletion, all of this. However, security in cloud is in fact slightly different to security on-prem. When we move servers and data workloads to AWS cloud, responsibilities are shared. There is a line between what we need to have responsibility on and what AWS will take care of. AWS is responsible for securing the underlying infrastructure. If we see here this image, we have the orange color AWS responsibility and the blue color customer responsibility. So regions, availability zones, edge locations, hardware, global infrastructure, compute, storage, database, networking, all the hardware. You remember before when we create or we establish a data center, when we do a race floor, air conditioning, uh, data centers, racks, servers, all these fans, all this stuff, this one done by AWS. This is not your responsibility at all. You pay as you go for this service, which is hosted in AWS servers in different regions with multiple availability zones. This is AWS responsibility. But what my responsibility, what I put on this environment. So customer data, platform, applications, identity and access management, IAM, operating systems, network, firewall configurations, client data encryption, server-side data encryption, networking traffic protection. So this is customer responsibility and this is AWS responsibility. We need to understand this one very well. This is another view of shared responsibility from service lens. So we have infrastructure services, we have container service, we have managed services. So for example, if we are talking about EC2, I hope everyone heard about EC2. EC2 like a PC on cloud or a computer you can configure in cloud, storage, network, IP, all the configuration you create for computer you can create in the cloud. So what is your role and what is AWS responsibility? AWS responsible about compute, CPU, storage, database, and the network, hardware, and the global infrastructure. But your responsibility is more. Data, encryption, network, firewall, configuration, client encryption, network traffic, all this your responsibility because it's infrastructure services. If it's container service, it is 50-50. The responsibility are shared in 50-50 basis. But if it's managed service means AWS have the major part of responsibility and you have only to take care about your customer data. So customer responsibility more if we go to infrastructure service and less if we are going to manage the service. I hope everything is clear now and now we can understand what the difference between or what the shared responsibility is. Here another view. So for AWS responsibilities, they are responsible about compute, storage, database, network, and the global infrastructure, availability zone, regions, and edge location. while customer responsibility is customer data, platform, application, operating system, encryption, and network traffic monitoring. So I will go here in some details in what exactly AWS security responsibility. So AWS is responsible for securing the global infrastructure that include regions, availability zones, edge location running in AWS cloud. These availability zones host multiple data centers that house hardware, software, networking, and other resources that run AWS services. Securing this infrastructure is AWS number one priority, and AWS is regularly audited by agencies over all the world to meet necessary security and compliance standards. These audit reports are available to customers from AWS, as a customer cannot visit AWS data center. So as a customer, I cannot visit the data center. Please show me where is data stored. Where is my data stored? No, it's not allowed. But you allowed to ask them for the audit report from independent audit agency to check the compliance and regulatory of these locations or data center. We need to understand this. So we are not allowed to check or to visit the data center, but we are allowed to ask AWS to provide us with audit report. Customer data and workload are stored in AWS data centers. These data centers are spread across geographical regions over all the world. These data centers are owned, operated, and controlled by AWS. This control include physical access and entry to these data centers and the networking component and hardware, and all other additional data centers that are part of AWS global infrastructure. So let's have a closer look here for what exactly they are secure. Physical environment. So again, as I mentioned, where is my data? Where are those physical servers and hard drives? Has my data located where? And how are those hardware resources secured? And who secure them? So AWS is completely responsible for physical and environment security of all hardware resources located in data center. This is very critical part of physical or shared responsibility model, where AWS does all heavy lifting instead of we worrying about our physical and environment security, which is the great part of cloud, by the way. We don't have to worry about monitoring, theft, intrusion, fire, natural disaster, power failure, all this stuff we have hassled before. These things are taken care by AWS on behalf of us, and they are constantly upgrade their security procedure to keep up with the increasing threats. Okay, what happened to the storage device? Decommissioning. I remember before I work in one of the biggest construction company in Gulf, and we have terabytes of data because drawing and the draft and stuff. Terabytes of data. And after we complete a project, we have a big problem to decommission these physical hard drives. So this stuff taken care by AWS. AWS initiated a decommissioning process. When the storage device has reached the end of life, this process ensures that customer data is not exposed to unauthorized individuals. So this hardware device will be physically destroyed if it failed to decommission. And they have standard process for this one. What about business continuity? AWS keeps our data and other resources in the data center in various geographical area. So this known as regions. So this is name geographical locations in AWS. They name as a regions. Each region has 2 or more availability zones for high availability and fault tolerance. These availability zones are made up with more data centers. So we have regions, availability zones, and each availability zones has multiple data centers. These data centers house all the physical hardware resources such as servers, storage, networking, everything. required to keep AWS services up and running as a part of service level agreement. All AWS core applications like compute, storage, database, networking are deployed in N+1 configuration. What is Magdy N+1 configuration? N+1 as a redundancy mean the facility has the capacity need to run a full IT load with an additional component to account if failure happen. So if they do a maintenance or failure happen or outage, whatever, they have another component to replace automatically. You don't care about or you don't have any problem. You don't have any downtime. Everything will run smoothly. You will not feel with anything. So all AWS core applications, such as compute, storage, database, networking, are deployed in N+1 configuration. So in event data center has failure due to a natural disaster or human unforeseen circumstance, there is a sufficient capacity to load balance. Don't worry. AWS Communication and Support. AWS offer 4 levels of support: basic, developer, and business and enterprise. It depends on how much and how criticality is your application. If you are a bank, maybe you need the highest level, 24/7 support, uh, response in 1 hour or 2 hours. It depends on criticality and how much you are afford to pay. These support plans give you a variety of levels of interaction with AWS support. What network security they provide? AWS network has been designed to allow us to configure the appropriate levels of security for our business. So they have secure network architecture. AWS has network devices such as a firewall to monitor and control communication at the external and the key internal boundaries of the network. So they have their own firewall. They have secure access point. So AWS monitor network traffic, inbound and outbound communication through endpoints, which is named API endpoint. This allow secure HTTPS through API signing process in AWS. Transmission, they use secure socket layer, SSL. Network monitoring and protection. AWS ensure a high level of service performance and availability by employing multiple automated monitoring systems. We'll talk about this one in coming slides. AWS access. AWS production network is logically segregated from the Amazon corporate network and required a separate set of credentials. So if you are employed in AWS and you have username and password for your company laptop, it is different than the username and password you need to access the production of AWS. So they use a complete set of network segregation between the corporate network and the production network. So summary on this one, don't worry about your security about data protected by AWS. In terms of shared responsibility model, again, we need to understand the segregation. So what is customer responsibility? As we mentioned, AWS shares security responsibility with customers for all what is offering. Essentially, the customer is responsible for security of everything that they decide to put in cloud. So think in this one like that. Anything you put in cloud, you have responsibility to secure, to protect. Data, application, resources, whatever. So customer data, customer application, operating systems, network and firewall configuration, customer identity and access management, instance management, data protection, data in transit, rest, and backup, ensuring high availability and auto-scale customer responsibility. So all AWS products that offered as IaaS, such as EC2, S3, VBC, this is completely under customer control because these services require customer to configure security parameters for accessing these resources and performing management tasks. For example, for EC2 instance, as a customer, I have responsibility for managing the operating system. I will use Linux, Windows, whatever, including updates, security patches, installation, maintenance, everything related to EC2. I have the power to configure and responsibility. So any application I will install, any utility, any third party, any application from AWS marketplace I decide to use, any configuration for firewall, anything related to this EC2 configuration, it's its customer responsibility. It's your choice to decide where you put your data, which geographical area. For example, if you have two locations, one in Egypt and another location in India, for example, and you decide to put some of your data in Mumbai data center to ignore the latency or whatever. So it's your decision where you want to put your data. You need to select your geographical location to store your data in cloud. The geographical location is known as region, as I mentioned before. So it is your choice to select which region you are going to store your data in. Also, it is your choice and responsibility to secure access to this data. And if you need to replicate this data between different regions, this is also your responsibility. Which regions you are going to replicate this data from and to. So customers always own their data and they have full control over encrypting, storing in a desired geographical location or regions, or moving it to another geographical location as a replication. As a customer, we need to decide on security controls that we want to put in place based on sensitivity of our data, because we have the complete ownership of it. They are not touching your data. This is another point I want to highlight. AWS, they don't know about your data. It is yours and your responsibility. And they give you a lot of tools and services. I will come through this one now to protect and encrypt and manage the compliance and the regulations if needed, if you are in banking sector or financial sector or healthcare sector. Let's talk about IIM, first security component and the most important security component. As I mentioned before, security now related to individuals. We need to protect our staff because everyone working from home, we are not working from same location, organization. Attackers now not attacking organization, as I mentioned, they attack individuals to get access to your network. So IIM, one of the most important, that's why I will take much time in this area, identity and access management. This is very important security control. I want to stress on the importance of this security control, because most of data breach happened recently or in the last 10 years happened because of weakness of IIM. How we manage our rules, users, access, privileges, access review, federation, single sign-on, multi-factor authentication. These all managed under IIM. So now we have clear vision about shared responsibility model, and we know that our responsibility is to protect IIM, identity and access management. So let's deep dive into the resources provided by AWS to secure our AWS account from unauthorized use. AWS give us a lot of tools, as I mentioned, such as MFA, several options for credentials that be used for AWS services, multiple use cases, secure endpoint communication, centralized logging service for collecting, storing, analyzing logs. Along with these features, also we have AWS Trusted Advisor that performs security check for all AWS services. I will touch base with all these tools in coming slides. All of these tools are generic in nature, and they are not tied with any specific services. So these tools are you can integrate or tied with any service you use inside AWS. So what is AWS account? Once you start create AWS, you start with root account. AWS terminology is root account. What is root account? Root account is account who has access, administrative level access for everything in AWS. This user account has username as email and password. These credentials are used to log in AWS Management Console, which is aws.amazon.com. It is a web application you can access from anywhere. Once you create this username and password, this is your root account. And this one has administrator access level for all AWS services. So one of the first recommendation and best practice, and one of the things I will highlight today many times, and you will hear me talking about this one, don't use root account for day-to-day operation. Okay, don't use this root account which you create initially for day-to-day operation. I will come to this point again. So what recommend is you need to create another account to do with required privileges, but keep this root account aside. Don't use it for day-to-day operation. AWS also have multiple credentials like password, access key, key pairs, and the X509 certificate. I will talk to this one later. Okay. So what is IAM? Identity and Access Management. It is a web service that help us secure control to AWS resources for our users. We can use IAM to control who can use AWS resources, such as rules, groups, users, and authentication, and what resources they can use. EC2, RDS, S3, and authorization, access management, what level of access they have, what permissions, what policies apply to them. So in simpler way, it is AWS allow us to control who can take what action on which resource in AWS. Again, AWS IAM allow us to control who can take what action on which resource in AWS. IAM manage users identity and permission access control for all AWS resources. It is a free of charge, so we don't have to pay to use IAM. It is a greater security control. And again, I would like to stress the importance of IAM as a security control. IAM gives you the ability to grant, segregate, monitor, and manage access for multiple users inside or outside your organization who need to interact with your AWS resources, such as S3 or RDS. So if anybody outside your organization need to access S3 bucket or need to access RDS database, you can manage this one through IAM. In AWS account, IAM integrate with CloudTrail, which is a great tool to logs. So you need to know, and at the end of the day, you will know who will do any change based on IAM identity. IAM is like a centralized location for controlling and monitoring access control for all resources. So we are going to walk IAM tools and features and some use cases. We will deep dive now to IAM authentication and authorization. And at the end of this one, we have a look on the IAM best practice. So Iim User. When we create Iim User in AWS as an entity, we allow users to log in or to sign in into AWS Management Console. First, we start by creating our root, which we are not going to use. So we need now to create user. So Iim User can be person, can be application, can be service. Okay, so it's not only user, which is can need to be interact with other AWS services. So when we create a user in IAM, we provide it with username and password to log into management console. We can also provision up to access key for IAM user when we use access key and secret keys, especially when we need to use AWS from CLI or API. When I talk about services, I mentioned IAM can be user, so user will use username and password. What about service and application? Service and application use access key and secret access key through CLI or API to interact with other AWS resources. This is also IAM user. We have three kinds of identification, like I mentioned here in the screen. One, the name, and the second one is ARN or Amazon resource name, and third one is a unique identifier, but is one hidden for us. Whenever we create a new IAM user through AWS console or CLI, they don't have any permissions. You need to understand this. So we need to create credentials for these users based on access requirement, what this user need to do. So whenever we create IAM user, we can assign permission directly to each individual. And the AWS recommend, this is second recommendation, to follow the least privilege principle. If user X need to access S3 bucket, which is named Y, we need only to give permission on this level, X to access Y. Not X to access Y and Z and H. No, X to access Y only. Least privilege. This is one of the best practice and recommendation from AWS. Second, we are talking about IAM groups. IAM groups like Active Directory groups. It is group of users allowed to manage permission for more than one user by placing them according to their job function or department. So for example, if you have sales department, you can create one group for sales department and another group for marketing, another group for IT, and you can define the rule permissions based on the group. So for example, if you have user in group A and he moved from group A from sales department to marketing department, you just move the user and this one will revoke all the access privileges he have from sales department to marketing department. This is one of the best practice when you create IAM or when you manage IAM to create groups and deal with groups. So for example, in this diagram we have in the screen here, we have three groups. We have admins, security, and developers. So root user can be simplified or simply created as an IAM. For example, Mary. We need to create Mary only as an admin or as a root user with administrator privileges. So we create root user and root user create Mary as admin. Once we create Mary as admin with administrator privileges, she can create others. Don't use root to create others. Mary with admin privileges can create Carlos, Anna, John as a developers, as security team, whatever. Don't use root. This another, I repeat this one many times. Don't use root for day-to-day operation. So you create admin, and with admin privileges, you can use create others. What rules we have in IAM? Or what is rule? What the meaning of rule? A rule is not necessarily to be associated with one person or application or service. Instead, it can be used by any resource that need it. Moreover, credential for rules managed by AWS, which is a good thing. If anything, you have two options. You managed or AWS managed, go for AWS. They are more mature, more secure, more professional. They know what they do. I don't mean that you don't know what you do, but they are doing with this one in daily basis. They understand the best practice. They are they have more skill set. So the rule managed by AWS. So it is recommended to use rules because these credentials also are created dynamically and rotated multiple times in a day. This one under AWS flag. Magdy, what rule can be used for? What's the use case? We can use rule for delegation access to service, application, or users. Or you can use rule to give access for somebody outside your organization. For example, let's talk about AWS Service Rule. If EC2 need to perform an action on behalf of us to upload some files to S3 bucket. So in this case, we are going to create AWS Service Rule for EC2 that assigns this rule to EC2 instance, and this rule will create, we define all the permission required to upload file to S3. So whenever files coming to S3, sorry, when we put any file in EC2, move directly to S3. We can create this kind of rules. So the rule will be created and the permissions will be on service level. This name AWS service level rule. Okay, what other rules we have? We have SAML rule. What is SAML? SAML, Security Assertion Markup Language. It is authentication protocol used by identity providers and service providers. So AWS allow us to create rules for SAML2 providers for identity federation. So if your organization is already using one of these provider software like Okta or ForgeRock, you can use this identity provider, which is create, maintain, and manage identity information. So some organizations have this kind of solutions. So they have ForgeRock or Okta to manage the identity for all the organizations. You can integrate this one with AWS through AWS SAML rule, and we can create through rules like this. As you can see in the image here, you can select your identity provider. So this rule create a trust between your organization and AWS as a service provider. And this help us to create single sign-on for the solution running in our organization. So if we have multiple solution, multiple software, multiple systems running, instead of having different username and password or different credentials for each application, we can use our Active Directory username and password to sign in for all this one with single sign-on by using this AWS SAML rule. Another rule is cross-account access. This rule supports two scenarios. First one is enabling access between our multiple AWS accounts, and second one, enabling access to our AWS account by resources in other AWS account that are not owned by us. Rules are primary way to support scenarios for cross-account access and enabling us. So we can use this rule for delegation of permission to another Iim user. There are cases where we need to provide this cross-account access to the object in our AWS account. This rule helps to simplify by provisioning cross-account access to various AWS services instead of having multiple policies and rules. Let's have one example. If you want to give through CLI to manage object in S3 bucket, you can give account B. So for example, now we have a user from AWS account A who need to access S3 bucket in account B, different account. So we create here a cross account rule. User from account A access files in S3 bucket hosted in account B through CLI by using cross account rule. Last rule for web identity providers. There are times where we need to provide access to resources in our AWS account for users who are not authorized to use AWS credentials. Sometimes we are not providing everyone AWS credentials. Sometimes they use web identity providers such as Facebook. Sometimes you need sometimes you see when you access web application, you have option to log in with Facebook, log in with Twitter, log in with Amazon. This is single sign-on based on web identity provider. They use OpenID Connect or OIDC. When users here authenticate by external web identity, so the authentication happen now through these providers, Facebook or Amazon, Google, whatever. So they will assign an Iim rule. So I will link Google or Facebook in the backend with Iim rule for web identity provider. So in this case, if this connection happen in the backend, this user will receive temporary credentials required to access AWS resources in our AWS account. Magdy, you are talking now a lot about identity provider, SSO, federation. What do you mean by all this expression? SSO is single sign-on, as I explained. You have multiple applications. You have time attendance application in your laptop. You have CRM. You have ERP, and you log in the morning with using your Active Directory username and password. Single sign-on allow you to use this application without using another username and password. You will log in automatically by using the same username and password. This is SSO, single sign-on. It is single sign-on. You one time you log in with your credentials for Active Directory, and you can use the same credential to log to your applications. This is SSO. Okay, what is federation? Federation, it is similar, very similar for SSO, but it creates a relationship or trust relationship between separate organization and third party. So when we have two domains are federated, user can authenticate to one domain and then access resources in other domain without having to perform a separate login process. For example, you have a contractor working with your organization. And this contractor, we have federation between the two domains, our company domain and the contractor domain. So if the user from contractor domain log in to his domain in his laptop, in his organization, he can access our domain or software we have in our organization. This is federation. And this is the difference between federation and the SSO. So SSO for the same organization, I can use all the application with single sign-on. Federated or federation, the user can use, if we have federation between two domains, two different organizations, and there is a trust relationship between them, we can use each other. And AWS support both providers, OpenID for federation and SAML2 for single sign-on. But, okay, what AWS recommendation here, Magdy? AWS recommended the use of something named Amazon Cognito. This is a service, a web identity federation services that act as an identity broker and does much more of federation work for us. So instead of having this kind of trust, and you need to create trust between different domains, if you have a mobile app or web application, Amazon provide us with a new service or a service named Amazon Cognito. What is Amazon Cognito? Amazon Cognito is a managed service that allow us to quickly add users to our mobile and web applications by providing built-in sign-in screen, as you can see in the screen. We have social identity. We can use Facebook, Twitter, or our user pool, or enterprise identity, like SAML. So it is a managed service, allow us to quickly add users to our mobile and web application by providing built-in sign-in screen. So you have built-in sign-in screen and authentication functionality. So it handles security, authorization, synchronization for our user management process across devices for all our users. So we can use Cognito to authenticate users through external identity providers like social providers, Facebook, Google. So you can use Google, Twitter, LinkedIn direct. No need to, if you are using Cognito, you can use direct this. It is already there. It is already implemented. The integration with AWS and Facebook, Google, Twitter as identity provider if you use Cognito. Also, Cognito can also be used to authenticate identities from other solution compatible with SAML2, like I mentioned, Okta or ForGrok or others. So they provide temporary security credentials with limited privileges to these authenticated users. This service primarily designed for developers. So all developers with us today, you need to get to this Cognito and understand how it works, because if you create mobile or web applications, it is very important to master these skills of and to understand how Cognito works. So it enables you to allow users to securely access your app resources. So you can access Cognito from Management Console, CLI, or SDK. Once we have created user pool, we can download and install integrate AWS SDK, whatever you have, iOS or Android. And if you don't wish to use SDK, you can also we have another option to use API directly. So you can call API directly for Cognito. And it will expose all the control and data for web services through API. One of the great features here Cognito has is it can integrate with CloudTrail and CloudWatch. So you can monitor the Cognito metrics, log API activities in real time. How many logs happen from which location, how many logs denied, how many logs accessed, when the user logged in. You can do a lot of analysis by getting this information and dashboards from CloudTrail and CloudWatch. Amazon Cognito provides you a solution to control access to AWS resources from our app. So we can define rules and map user to a different rules. So from Cognito, you can define rules and permissions. Who will access what, and give authorization based on that. Another thing is adaptive authentication. This is another great feature from Cognito. When Amazon Cognito detect unusual sign-in activity, such as sign-in attempt from new location and new device, it assigns a risk score for this activity and let us choose to either ask users for additional verification or to block sign-in request. So users can verify their identity using SMS or one-time password OTP generator like Google Authenticator. This is one of the great features of Cognito, and I really recommend developers to look at this tool if they are creating mobile and web app using AWS. Protection from compromised credentials. Another features from Cognito help us to protect our application users from unauthorized access to their accounts using compromised credentials. When Amazon Cognito detect users have, now we can detect if your email is already compromised or not. Cognito have these features and this database. So if you are using an email which is already compromised, it will give you alert to change your password. So if your username and password compromised somewhere, it will give you alert to change your password. And it is support multiple compliance programs like ISO 27000, HIPAA for healthcare system, ISO 9000, ISO 9000 compliant. So it supports multiple compliance regulatory. And they have also built-in customizable UI to sign users. Another terms we are using here in AWS IAM rules, like delegation. What delegation means? Delegation means granting permission to users in another AWS account to allow them to access resources in our own AWS account. So you are delegating somebody to use resource in your account. This involves a trust relationship between two AWS accounts. This trusting account owns the resources, and the trusted account contains user need to access the resource. can be the same account, يعني two users in the same account, or two accounts that are in both under same organization, or two accounts owned by separate organization. For delegation, we start creating Iim rule with two policies. One is permission policy, which is take care of permissions required to perform actions on AWS resource. And second one is trust policy, which is contain information about trust accounts that are allowed to grant its users permissions to access this rule. Another terminology used here is temporary security credentials. Sometimes we have situations where we need temporary credential, temporary access for contractor, for supplier. AWS provide us with this feature also under Iim. They have service name STS, Security Token Services. With this one, we can create a temporary users to access AWS resources. And AWS recommend using this credential over permanent ones because they are more secure and managed by AWS. Again, use tools managed by vendor, whoever the vendor, AWS, Google, GCP, use the tool native security control. They name it like this is the terminology named in the industry, native security control. Use native security control. So if AWS or GCP or Microsoft recommend using something, please go and use this one because they care about this one. They are going to secure that one. They manage that one. So temporary credentials are useful in scenarios that involve identity federation. If you are going to federate between two domains, so the temporary is it's good use here. Delegation, if you are delegating something for somebody to access resources in your own AWS. Cross account access, Iim rules. These all a good use case for temporary credentials. These credentials are very similar to access key credentials that are created for Iim users, except for few different things. It is very similar. But when we configure STS, it is valid only for minimum 15 minutes to maximum 36 hours. Okay? And the default value is 1 hour. So we can configure it to 15 minutes, 36 hours validation, I mean, it will expire after this one, and the default value is 1 hour. And once this credential expire, AWS no longer recognize them, and all requests will be declined. And unlike access key, which I talked about before, when we need to services or rule to access CLI through CLI or SDK, it is not stored locally with the user. It is temporary. It is not stored anywhere. It is stored only and managed by AWS because they are generated dynamically and provided to the user when requested only. This is a very great security feature. So the following features are for using temporary credentials. One is we don't have to distribute or embed long-term AWS security credential with our applications. Developers, please hear me. No need. So we don't have risk to losing these security credentials if application is compromised. If your application is web application is compromised and AWS security credentials are stored, it is a big risk. But if you are using these features, you are not at risk because it will expire maximum by 36 hours. We can provide access to our AWS resource to users without creating identity for them. So it keeps our user management lean. One of the best practice from the industry we are facing every day, and I want to highlight here also, user access review. You need to do user access review periodically because sometimes people left the organizations and the credentials still there. They still have Active Directory user. They still have email access. This is one of the big risks for organization, especially for people who resign or left the organization. I am sure many of you now, yes, you are right. We have this situation. So Timbre credentials is good, uh, a good tool we can use here. So also the temporary security application have a limited lifetime and they are not reusable. So once they expire, it is not reusable. We don't have to worry about defining a credential policy or ensure that are rotated periodically because it's one managed by AWS, as I mentioned. The root user, as I mentioned before, this is the one we created firstly when we create AWS account, and we don't use this one in operation or day-to-day operation. Okay, what the root user can do? Root user can change the account information, change root user password, update the payment information, billing, support plan, and change our AWS account, or sorry, closing AWS account. So this is the main tasks or rules root user can do. Change root account information, such as changing the root user password, updating the payment information, updating the support plan, and closing AWS account. We're taking a long time here. Uh, Iim authorization. We have different component for authorization. We have permissions and policy. Permissions is, let me talk about action in AWS. It allows users AWS identity to perform tasks in AWS. When we create new user, except for root users, it comes with no permission, as I mentioned before. So we need to give a permission for this user. We can give permissions in two ways, identity-based or resource-based. What's the meaning, Magdy, here? We can assign permission based on two things, identity or resource. Identity, these permissions are assigned to AWS identity, يعني per user, per group, or rule. So for example, we can give user X to read S3 bucket and provisioning AS2 instances. This is identity based on rule, users, or group. The what resource based? I can give permissions to resource like AWS S3 bucket. So this S3 bucket will be accessed only by user XYZ. Okay, so permissions give based on two things, identity based and resource based. There is another terminology used, resource level permission. What's the difference between resource based and resource level permission? Resource based are based on resource, EC2, S3, RDS. What level permission? It is a level deeper by giving ability to, for example, for S3, I need give permission to list only uh, information in S3, or to delete, or to add, or to write. This is resource level permission. But resource based, it is overall on the on the resource itself. Okay, what is policy? Policy is a document listing multiple permissions, and it is written in AWS in JSON format. So a policy can be more or one statement, and each statement describes one set of permissions. You need to understand these definitions and this what's the difference between this one and this one. We can attach more than one policy to one entity, and each policy had its own. Do you remember what ARN? Amazon Resource Name. That include policy name and entity in IAM. And the policy has three components: action, resources, and effect. What action will be taken, what resource will be affected by this one, and what effect will be on that one. Read, write, deny, allow. I will be more quicker because time is flying. Another Iim policy tools. First tool I will talk about Iim Policy Simulator. Iim Policy Simulator help us to test as well as troubleshoot policies, both identity and resource based. This tool is quite helpful for testing the scope of existing policy. please utilize this tool. When you create, if your role in your organization to create policy in AWS, use these tools. This tool will help you a lot. So Iim Policy Simulator, it is helpful for simulation and troubleshooting your policy. If it is identity, as I mentioned before, or resource-based. We can find out if a policy is allowing or denying the request action for a particular service. Okay, for a selected Iim, like I see here on the screen. And since it is simulator, it doesn't make any actual AWS request. This tool accessible for everyone from management console. Second tool is validator. Validator is to fix our non-compliant policy in Iim. So we will know that we have non-compliant policy if we see a yellow banner. If we see this yellow banner, policy syntax, it means we are non-compliant with regulatory. So that means we have syntax error, or we have JSON syntax error, or policy grammar error. We need to fix. This one check only two things: validator, JSON syntax, and the policy grammar. It doesn't check variables like ARN or policy condition keys, whatever. It only checks these two things. We can access this policy validator while creating a policy, or we editing, or we viewing the policy after that. Second tool we have is Access Advisor. As we see here, Iim console give us information on policies that were assessed by a user. This information very useful to implement the list privileges. You remember my recommendation from the best practice is to use list privilege principle. So if we find here one user have access, and for example, last row here, ELB didn't access from 314 days ago. It means no need for this user to have the access for ELB. After we confirm this, we can revoke this permission to give him what exactly he need to access. So through Access Advisor, we can find out what permissions are used infrequent or permissions are never used. So we can revoke this one and use the list privilege principle. Another one is password policy. We can set up password policy for our AWS account. So whenever you create a user, you can ask them to check box for use uppercase, lowercase, all complication we know about password, expiration date, password rotation, prevent password reuse, how many times. You can define all these capabilities under password policy. Another great tool is Iim Access Analyzer. Access analyzers identify resources shared with external principals by using logical-based reasoning to analyze the resource-based policy in our AWS environment. So for each instance of resource shared outside our account, Access Analyzer generates a finding. We need to review this finding to determine whether the access is intended and safe, or access is a potential risk. So it is very important rule. So we identify resources shared with an external. So when we give access to external entity, contractor, supplier, as I mentioned before, or consultant, we need to analyze this access. So we can use Access Analyzer finding to preview how our policy affect the public and the cross-account access. You remember cross-account access I talked about before. So it is very important to analyze this access. Once you enable this one, after you apply all the policy, Access Analyzer will analyze the policies applied for all supported resources in our trusted zone. After first analyze, Access Analyzer will analyze these policies periodically, automatic. So if we add new policy or change new policy, the tool will run and update the policy, analyzing for after 30 minutes. So if they found or they identify we are granting access to an external principal that isn't within our trusted zone. So for example, if we create trusted zone with supplier X and Y, and they found another access coming from uh, O, organization O, this is finding. It gives us a detail about the resource, what is the external identity access, and what the permission granted to them. This finding need you to review and to check and to update to secure your organization. Sometimes it take, if we are talking about multi-region access, if you create policy for multi-region access, sometimes it takes some time, maybe 1 day to do update. So don't worry about that. What is AWS credentials? We have email and password. We have Iim username and password. We have multi-factor authentication, and this is very important. I will stress on the importance of multi-factor authentication because it adds additional layer of security to our AWS account. So when we log into AWS console by using username and password or email address and password, if we are a root must have multi-factor authentication enabled. Must have. And if you are aware about what's going on in the industry right now, they are talking about passwordless. Passwordless, they are talking about you don't need to remember your password. You are going to use authenticator like Google Authenticator or Microsoft Authenticator with built-in biometric in your laptop, like finger or face. So you don't need to use your password anymore. This is a new thing is coming in the business or in the area of security, passwordless. So MFA is very important part because you will use multi-factor authentication in this one. So we can set up MFA on hardware device like USB, or we can have a virtual token like as I mentioned about authenticators. So it is highly recommended to use multi-factor authentication. Access keys and as I mentioned before, access key and secret keys. These keys are used with SDK and the API to access AWS, and this one need to be stored in secure place. Key pairs constitute a public key and a private key. The private key is used to create a digital signature, and the AWS use the corresponding public key to validate this digital signature. So this key pairs used only for two services, EC2 and Amazon CloudFront. So this one, a key pairs used for EC2 to remotely logging, or for CloudFront use key pair to create signed URL for private content. AWS also use account identifiers. AWS provides use two unique ID for each account that serve as account identifier. ID and canonical user ID. ID is 12 digit and the other one is more than 36 characters. X509 certificate, it's a kind of security certificate designed to carry out a public key and bind with a key in identity. This certificate used public key cryptography, and we can either use this certificate generated by AWS or upload our own certificate. What next? What happened if our IAM rule compromised? So if misconfigured rules happen, if a hacker can enumerate our rule names and misconfigured our rules, then he can enumerate session token permissions and get access to our EC2, S3, or KMS. Then he can enumerate EC2 to get user data and get a list of S3 buckets. If he get access to S3 bucket, he can get encrypted object from S3 and decrypted by service credentials by KMS decrypt, and get more access to more services. So this show you what's the importance of having strong IAM. I will show you now the best practice you need to have in order to have strong IAM rules. So if you observe any unauthorized activity within your AWS account, or you believe that is unauthorized party accessed your account, then you need to do the following. So if you feel that something wrong, you need to do the following. One, rotate and delete all root and AWS identity and access management access keys. Change and delete all root and AWS identity access management access keys. Delete any potential unauthorized IAM users, and then change the password. Check your pill and AWS config, because your pill can help you to identify any new resource, any new S3, any new EC2, any new Amazon EPS, Elastic Block Store created. This one give you, there is something went wrong in my environment. I need to take care. I need to have a look. I need to investigate more. Okay. Enable multi-factor authentication on root users and any IAM user with console access. Enabling MFA can help you to secure your accounts and prevent unauthorized users from logging to these accounts. Verify that your account information is correct. And lastly, respond to any notification coming from AWS support. Don't ignore any email coming from AWS support, because also I have cases, some customers, they receive notification from AWS support and they just ignore. It's like a spam mail. What is the best practice? Lock root account keys. Keep it in a safe place. It is a very, very important thing. Lock root. This is the best practice. Lock root account keys. Don't share credential with anyone. Use managed policies, like I mentioned before. Use group to manage users. Follow the least privilege principles. We explain this one. Review Iim permissions. User access review. One of the critical and most important thing in Iim. Enforce strong password management. Sorry. Enable MFA. Use rule for applications. Use rules for delegations. Use rules again. Rotate credentials. Use policy conditions. I mean policy attributes. Monitor account activity. This is best practice from Iim perspective. Second, we are going to talk about VBC. VBC is a logically separated and isolated secure network. This is from network perspective. First, we talked about Iim. Now we are talking about VBC. Time is flying. VBC is a logically separated, isolated, and secure virtual network on the cloud where we provision our infrastructure, like RDS instances or EC2. So it is like a virtual network on cloud. So what component we have in VBC? We have ENI, subnets, route tables, internet gateway, elastic IP address, and the VBC endpoint. I will talk about this one very quickly. Here we can understand, we can see we have public VBC, private VBC, internet gateway, endpoint, VPN gateway, VPN connections, what all this. This is like all the network we have on-prem, we move it to cloud. Very similar structure, but software defined. So subnets, we know about subnets from traditional network, but we don't know about ENI. What ENI? ENI is Elastic Network Interface. So ENI are available in EC2 instances, which is running under VBC. ENI can have multiple attributes. It has IP version 4, MAC address, one or more security groups, one or more IP version 6 addresses, and so on. By default, every VBC has one interface for network interface, one ENI. This ENI is known as a primary network interface or Ethernet 0. This default ENI cannot be detached from VPC or from an instance, but we can, however, create and attach many additional ENI. Routing tables. Routing tables, as we all know, routing. What's the flow of information? What's the route table? And by default, we have a default route table. So VPC by default have a default route table, and this is the main route table. Okay. So it is decided as routing table what data stay inside the VPC and which data is going outside VPC. Internet gateway. Internet gateway, if we have a private subnet and we need to give access for this private subnet to internet, we need to have internet gateway. So this private subnet have access to internet through internet gateway, like we see here. So this and once it has this exposure to internet, it is be public VPC. So private doesn't have access to internet gateway, but the public one have access to internet gateway to get access to internet. Like for example, if we have website hosted in one of these EC2, and we need people from outside to get access to this one to a public subnet which has access to internet gateway. We have also something named elastic IP address, EIB. Elastic EIB address, as I mentioned before, if you have a website, this website should have static IP, not dynamic IP, which it change if you restart your EC2 or you shut down EC2 and open again, it will giving new IP. You need to have a static IP, link it to this website or web address. So we need to have elastic IP address. VPC endpoint, we can see here on the right. This VPC endpoint is a secure way to communicate with other AWS services without using internet. But this only work with S3. So if you need to give access to S3 bucket outside your VPC, you can use endpoint to give access to your EC2 to that S3 by using endpoint. NAT or network address translation. We need to access internet occasionally for if you have private subnet, public subnet, we don't have any problem because it already have access to internet through internet gateway. But for private, if you need, for example, to update system or to have patch management or to update patches or whatever to any of AC instance which is already in a private subnet, which is the net, you can use NAT. So the NAT device is used exactly for this purpose. So allowing resource in private subnet to connect with internet or other AWS service securely. This is a component again, or another view for the component. What's the use case of VPC? We can host a public facing website in VPC with a single public subnet only. No need for other. We don't need any private. We can use our VPC with a single public subnet with security group to allow inbound traffic with HTTP or HTTPS from internet and restrict outbound. Very simple, easy to configure. So this is one use of VPC. You can use it to host a website. So you will host a website in public subnet. Now you understand what's the meaning of public subnet, which has exposure to internet. We can have the EC2 hosted the website, have elastic IP address, have access to internet on security groups like a firewall for on instance or in EC2 level. We can define, for example, open port for HTTP and HTTPS only from internet to the EC2 and restrict or any outbound. We don't need to have any outbound traffic. Another use case is hosting multi-tier web application. Sometimes you have web interface which need to be in the internet and the database can be on private subnet. No need to have any exposure in internet. So if you have multiple layers, multiple tier, you can put your database in private subnet, and you can put your whole website in a public subnet, which is have exposure to internet. So this is another use case. Third use case is creating a branch office and the business unit network. This requirement can be fulfilled by provisioning instances within a VPC with a separate subnet for different branch offices. So you can have different subnet for each branch. Fourth one, hosting web application in AWS Cloud that are connected with our data center. You can extend your network by having a VPC connected to your data center. And you can connect to this network by IPsec hardware VPN between your VPC and your corporate network. This kind of expansion can be extending corporate network in AWS Cloud. This is also applicable when for data centers that reach it. So, for example, if your data center reached the peak in capacity and you don't have room to extend, you can use AWS Cloud to extend by having this VPC. Another use case, which is I have many scenarios like this, disaster recovery. Some customers use VPC as a disaster recovery for business continuity plan. How? They need to critical data in DR site. So we can VPC to host EC2 with EBS volume and store data in S3 bucket. They can put all this under VPC. So, and they can put all the critical information there, and they can host it in a private subnet, so no exposure to internet. And once they have the recovery or the continuity plan or the reason of outage gone, they can replicate the data back again to the data center. Security group, I mentioned before, if you want to open some port to get access, it is a virtual firewall to control ingress and egress traffic at the instance level for all instances in your VPC. And each VPC has its own default security group. Vbc Peering Connection is a network connection between, is like a trust relationship, which I talked before, between two VPC. If you have VPC A and B, you need to give access from A to B. You can have this trust relationship and the VPC peering between both. Network access control list, like our ACL we have before in our all the days in network. It is network access control list, which it is another virtual firewall provided by VPC to configure inbound and outbound traffic from VPC subnets. I am going very quickly because we have a lot to do and the time is VBC Flow Logs. This Flow Logs is very important security tool because it helps us to monitor the security of our network in AWS Cloud. So we can create Flow Logs for our VPC as a subnet and a network interface based on our requirement. So we can monitor all the logs coming out and in, and this helps us to troubleshoot issues related to traffic. So for example, if you have traffic not reaching destination or vice versa, we can understand what's going on from the VPC flow. So it facilitates the flow of inbound and inbound traffic, and we can understand here from the graph all the information coming like account ID, ENI ID. Now we understand what ENI and destination source port, destination protocol, packets, and so on. VBC connectivity option, we have multiple options to connect to VBC. We can connect through hardware VPN or direct to connect, and this one available through some suppliers and some partners to AWS. You can get 1 gig or 10 gig, I think 10 gig or 1 gig, yes, direct connection to through fiber to AWS direct. So you can have direct connection between your corporate network and and AWS through some partners by getting 1 gig or 10 gig fiber connection. We can use AWS VPN Cloud Hub or software VPN. So what's the best practice for VPC? Plan your VPC before. Plan. I am a big fan of fail to plan is plan to fail. Planning is very important. Plan before moving to cloud. Plan your VPC. Plan your IAM. Planning. Choose the highest. Spend more time on plan. I need to stress on this. Choose the highest CIDR block to give you expansion in IP addresses, because it's very hard or sometimes impossible to change this one after you create your VPC. Use unique IP address range. Leave the default VPC. Don't touch this one. Design for region expansion. You don't know what's going to happen tomorrow with your organization in terms of expansion. Follow the least privilege principles again and again. Keep most resources which is don't need to have access to internet regularly on a private subnet. Create your VPC for different use cases. Don't use the same VPC for everything. Favor security groups over NACLs because it's stateful, not stateless. IAM your VPC using peering, trust relationship between VPCs. Use elastic IP for public IP because no need to change your IP if you're having, for example, a website or web application. Tag your VPC. Tag everything in AWS. Tagging. Tagging is one of recommendation because you can do filtering, you can do protection, you can do all kind of security based on the tags. Monitor your VPC through VPC logs or integration with CloudWatch and cloud monitoring. Next, data. Data security in AWS platform can be classified into two broad categories. Data at rest or protecting data at rest, which is mean data stored on disks in Amazon S3 data centers, or protecting data at transit, data travels to and from S3. All AWS services offer the ability to encrypt data at rest and in transit. So this you need to capture. All AWS services offer use this feature. Use encryption. Encrypt your data on cloud. So if something compromised, it is encrypted. And one of the great tool here they have in AWS KMS. AWS KMS integrate with the majority of AWS services. So and this one give you full control, the life cycle and the permission and the keys of encryption. So now data in rest, data security in rest. S3, Amazon S3. Amazon S3, one of the major and the most commonly used storage everyone knows about. If you know S3, if you know Amazon AWS, you know S3. So it is have a wide range of file storage, archival record, disaster recovery, and web hosting. So AWS have multiple features to protect your data, like encryption, MFA, versioning. Versioning is one of the critical and important thing in Amazon S3. And some organization use to back up all data in S3 because versioning. If you have data backup last week and the same data overwritten, you have versioning. You can keep versioning in S3. So if you enable this one, it's one of the great feature in Amazon S3. Also, they have storage glacier, which is low cost. You need to think about this one also. When you store data which is not accessible too much, you can store your data in glacier. Permissions. This is another category of securing data in rest. So you can give permission option to at bucket level or object level. This is also one of the great features to protect or secure your data. Versioning, I mentioned before. Replication. Replication, you can enable replication in S3 level, which is keep your data durability by 99.99%. You are not going to lose your data. Your data is backup, replicated between different locations. different regions. Server-side and client-side encryption. Amazon APS. Amazon APS is like elastic, elastic, elastic block. Sorry, elastic block storage service provisioning by you can use by, so for example, if you have EC2, you can provision EPS, and this EPS you can encrypt your data on. Okay, replication I mentioned about, backup, encryption, RDS, Amazon Glacier I mentioned about Amazon Glacier, and this use encryption for ES256 for all the archive. Amazon Dynamo AP DB you can use to encrypt the base 64 encoded. EMR for big data platform. Then we are talking about data in transit. How you secure data in transit? You can use S3 also. You can use Amazon RDS, Amazon DB, EMR, KMS again, and Cloud HSM, and Amazon Massey. I will touch base with KMS because KMS is one of the great tool here. KMS is fully managed service that support encryption for our data at rest and data in transit. So KMS can use, it's a fully managed I mean under AWS. So it is support encryption for all your data at rest and in transit. And AWS KMS will create and manage keys that are used to encrypt your data. And it provides you with fully managed and highly available key storage management and auditing solution that can be used to encrypt data across AWS services, as well as to encrypt data within your application. And it is low cost, as a default keys are stored in your account with no charge. So we pay only for key usage and for creating any additional master keys. This is one of the greatest tool in AWS. Here I mentioned about KMS and benefits, integration, centralized, secure, and compliant, fully managed, and what's the component of KMS. Another great tool is AWS Cloud HSM. So Cloud HSM is a fully managed service also that take care of administrative, time-consuming tasks like backup, software update, hardware provisioning, and high availability by automating these tasks. It's like automation. It is includes secure key storage and high-performance crypto operation. It used like DevOps. And it can be quickly scaled by adding, removing HSM capacity on demand with no upfront cost. What main features? It can generate and use encryption keys using HSM, pay as you go, easy to manage, and we can use to protect the private keys for issuing certificate authority and enabling transparent data encryption. Another tool is Amazon Massey. Amazon Massey is a newest security service powered by artificial intelligence. This tool uses AI launched by AWS to use machine learning to identify, categorize, and secure our sensitive data that's stored in S3 buckets. It is continually monitoring your data and send alert. This is one of the nice tool and the greatest tool because it uses machine learning and AI. So it send alert when it detect any anomaly in your usage or in the usage or access pattern. So it use template function for to send alert and revoking unauthorized access. Servers. To protect our servers, we need to use Iim rules for EC2 instances. I mentioned this one. To manage OS level access on Amazon EC2, you need to manage your credential for operating systems. Protect your instance from malware. Instance in AWS should be protected from malware like virus, Trojan, and spams. this protection happen from AWS. Secure your infrastructure and use IDS and the IBS, and AWS don't have a solution for this one, but they have solutions available in the marketplace for IDS and IPS. Elastic load balancing security, building threat protection layer, and testing security. By the way, you can do pen testing. This is one maybe interested you. You can do pen testing in AWS for only these services: Elastic, Rational Database, Aurora, CloudFront, API Gateway, Lambda, Lightsail, and DNS Zone Walking. These services only you can do pen testing in AWS. Sorry, I'm going very quickly because the time is best practice to secure EC2: list access, list privilege, configuration management, change management, audit logs, ACL security groups, API access, data encryption. One of the tool or security tool we can use is Amazon Inspector. Amazon Inspector is an automated agent-based security and vulnerability assessment services from AWS, and it enforces security standard and compliance, increase deployment agility, leverage AWS security expertise, and integrated with most AWS services and partners. And this is a component of Inspector: run assessment, AWS agent, assessment target, finding, rule package, and assessment report. Shield is a great tool in AWS, and it used to uh, customize protection for it is, the DDoS. It is the main tool to prevent or protect your environment from DDoS attack. AWS Shield, because it detects and automatically mitigate attacks that could potentially result in a downtime for your application. So it is one of the great tools to protect you against DDoS attack. Another application is WAF, AWS Web Application Firewall. This one increase the protection against web attacks, security integrated with how you develop your application, easy to deploy and maintain, and improve the web traffic visibility. You can understand how the traffic it goes to your web application, and it's cost effective in web application development. Another great tool is API Gateway. API Gateway is a low cost and efficient tool, and it is important for developers because we have to work with APIs and on regular basis. Amazon API Gateway is a fully managed web service that help to manage, publish, maintain, monitor, and secure API. It is mainly for API and any workload running in EC2 instance or AWS Lambda and any web application. And you can use API Gateway to manage, authenticate, and secure hundreds of thousands of API calls. Monitoring CloudWatch is a great tool, and we can use for monitor EC2, monitor other AWS services, monitor and store logs, set alarm, dashboarding, automating reaction to resource change threshold. One of the great tool for monitoring. And the component of CloudWatch is metrics, dashboard, event, alarm, insights, and log monitoring. Logging, uh, best practice for logging, log access and the audit information should be collected in auditors. You need to have logs for everything, especially if you are in a regulated industry like banking or healthcare or whatever. Ensure that all log data secured and with access control and stored in durable storage solution like S3. Life cycle policies should be automated in storage, and this one available in S3 bucket. Follow standard naming conventions so you can understand this log data coming from where, coming from front logs, coming from S3, coming from ALP. You need to have standard naming conventions. Use centralized log monitoring solution to consolidate all logs and do analyzing and actionable action. So what tools available for or what logs available from AWS? We have CloudTrail, AWS config, billing report, access logs, S3 access logs, ELP logs, CloudFront access logs, RDS logs, VBC Flow Logs, and the CloudWatch logs. These all logs need to be centralized managed. We have here CloudTrail. You can utilize this one to manage all the logs under one umbrella. So it is simplified compliance, user and resource activity visibility, security analysis and troubleshooting, security automation. This tool from Amazon to manage logs. What's the best practice for CloudTrail? You need to enable CloudTrail in all regions you are using. Enable log file validation. This is used to ensure integrity of log file. Always encrypt logs at rest to avoid unauthorized usage, because hackers or attackers can use logs to understand about your environment. Always integrate AWS CloudTrail with CloudWatch log to configure metrics and alarms. Centralized log from all AWS accounts under one umbrella, as I mentioned. Enable service access logs for S3 bucket. Enforce multi-factor authentication and use IAM to restrict access to S3 buckets which store CloudTrail logs. Excuse me for I'm very quickly because again because of the time. AWS config, this one for auditing. We can use configuration history for AWS resources. We can use configuration history for software. This AWS config like give you history for all the configuration you have. How when you delete EC2, when you delete S3 bucket, what how many S3 you have, buckets you have, how many EC2s you launch. Another great tool is Trusted Advisor. It provides you with recommendation and real-time guidance on the following 4 areas. Cost optimization. This I recommend this tool to be used. Performance, security, and fault tolerance. Security Hub, it is really a new tool and have a lot of features because it gives you like a security posture. And I see Ahmed Baha asking question today about, do you have a security posture solution? Yes, AWS Security Hub, it's like giving you a security posture about what's going on in your environment. It is integrated with all security tools in AWS and giving you access, dashboarding, metrics about what is your situation, what security situation in your environment. What of the great features? You have automated continuous security best practice checks. They consolidate the findings across AWS services and single standardized data format for all findings, security standard aligned, regulatory, automated response. They have also response automated remediation, so they can take action from a security hub if something went wrong or any authorized action or any abnormal behavior happen. Multi-account in AWS organization support. It can be integrated with ticketing, chat, incident management, investigation, GRC, or any SIEM tool. Security score and summary dashboard, filtering, grouping, and saved search. This is a great tool for security posture for your organization. Another good tool is Amazon Guard Duty. And the Guard Duty is a threat detection service that continuously monitoring any malicious or unauthorized behavior. And by the way, you can integrate Guard Duty with Security Hub. What features? It is continuously monitoring your AWS account, threat detection through reconnaissance, instance compromise, account compromise, bucket compromise, anything, give you alert directly and send you email or SMS how you configure the tool. What's the golden rule? For golden rule to secure cloud environment, whatever vendor you use, know your cloud security posture by tool like Security Hub or any other tool. Automate native security, use automation, use CID, use native security control from vendors. Be proactive with compliance. This is one of the golden rule. Employ security monitoring and response, and automate security monitoring and response. I think this is the 4 golden rules to secure your cloud first journey. What solutions? This is here another like recap for our session today. What solutions available from IAM, detection, infrastructure protection, data protection, incident response, compliance, summary, what Iim best practice we discussed, what VBC best practice we discussed, what data security best practice, what servers best practice, what application best practice, what great resources we have. You can use AWS documentation. You can take a snapshot of this slide. AWS white papers, AWS case study, YouTube channel, blogs, and the marketplace. This is and AWS white papers and documentation is a great case studies. This is a great source of information to learn and understand. And they have a lot of free trainings. You can get a lot to know about this one. I don't like you to be in this age when you realize the importance of security in cloud and AWS especially. I hope I can give you some information and add value to you today about AWS and security. And again, I'm not recommending any vendor here, but I give my perspective and my view for AWS and how you can protect your environment. Please reach out to me if you need any help, any kind of support. My LinkedIn profile is there, and you can post your question in Hova. I'm very happy to be here again with, and I would like at the end to thank Arab Security Conference for giving me this chance and opportunity to present here for second time. And have a great day. Thank you.